Okay, so today, part of the just vector database deep dive, talking about how exactly do agents actually go and get that information. It it can get kind of technical, especially when you get into the cosine similarity and you get into these functions and formulas. So we're not going to do that. We're going to just talk about this kind of stuff with natural language and just the way that agents kind of do it, because you don't need to understand those formulas and stuff. I mean, if you really want to, I would probably go look up a video and have them explain it to you. But this is the way that the average person who's going to develop some of these sort of applications needs to be able to understand it. So you know, obviously in AI applications, we're going to have, especially with tools like N8N, understanding how these searches work is important because you need to get your information in there right, and you need to understand whatever the use case is. You need to understand how you can get back what you're looking for. So at this point, we should understand how vector, data representation works. Items are stored into these vectors right here. As you can see, each point is going to be a different vector, and these are being stored as numerical representations of data. We've talked about our embeddings, we've talked about the different dimensions, and that's sort of how each of these points here have like meaning. So the whole point is that we're able to look for things that are similar based on the context of what they mean and based on the context of the embeddings the dimensions, rather than just an exact match. Sort of like a Google search, we're not looking for Apple and only things that have Apple. We're looking for things that are similar to apples, or fruits in general that have different characteristics like apples. Um, so that's sort of how that works, right? So when it comes to working with agents, um, they are going to be doing this kind of stuff using RAG. So obviously, we understand that they're going to hit the vector database with a query, and then that query is going to go in, and that's how the process of retrieval, augmented generation happens, because the agent uses the vector database to search within our vector database through these vectors, return back the ones that are most related, and then bring that answer back to the agent in order to make information for us to digest. So I guess the vector database doesn't return an answer. The vector database returns the vectors with their information, and then the agent makes an answer based on that kind of stuff. So when it comes to, you know, how does that actually happen? So this is our vector database, and then this blue dot here is the query. So basically, we send off a query to the vector database, and that query gets vectorized. So just the same way that when we upload information into Pinecone for it to be vectorized and given dimensions, our actual search query gets vectorized, and it's placed somewhere within our three-dimensional space. And then basically the way that we're doing it is with similarity measurement. So we're looking for the nearest neighbor. The system then searches for the vectors in the database that are closest to the query vector. So these nearest neighbors represent data items that are most similar to the query, obviously. The closeness is determined using, in this case, similarity metrics. There's other ways that you can do it based on, this is where I said the cosine similarity and looking at other sort of different formulas to determine what's the most relevant. But basically, nearest neighbor is the way that I think that N8N AI agents just typically will go search for throughout this throughout this dimensional space what vectors are going to be pulling back. And so when you want to get technical about it, there's different ways you can configure this, whether it's I just want the k nearest neighbors, so 5 or 10 nearest neighbors, or I want to define the range that it's going to look. So I want to look this far, and then anything within this radius will be pulled back. But yeah, that's just getting a little more technical, and we can talk about that at some point. But anyways, because it identifies the nearest neighbors, the agent is able to retrieve obviously the most related items. And so that's why when I talk about the difference sometimes between structured and unstructured, and it's not always going to be exact information you're getting back. Sometimes it's going to be like information or similar information. And so that's why sometimes there's the case where you want to use a SQL database in order to filter through different rows. But this visualization I think should help. It shows that the query gets put in here, and then we're grabbing the most relevant things. This was just I just made this real quick to show, like visually, we hit here, and then from this point in this RAG process, let's say we ask for something specific, we'd get the query put there, and then we'd grab these closest ones, hit back the vector database with the information, and then that would go back to the AI agent. So basically, the reason I'm trying to explain this is because specifically in N8N and when you're doing AI agents that have to use, RAG, you need to understand like there's vector search allows the agents to obviously comprehend the process and the queries based on the semantic search. It's going to make the information retrieval process more efficient because it identifies nearest neighbors. Agents can quickly retrieve and parse through that information in these huge data sets. It's larger than just these yellow dots I put in here. Obviously, the bigger it is, the more important it is to have, quick response times, accurate results, all that kind of stuff. And then, yeah, that's kind of the main point I was trying to make here. Just understanding that, the concept of how this works. And just sometimes, like this stuff can seem complicated, and just trying to break it down to understand, how this works. And it's not always one of those things where if you didn't understand this concept, if you didn't understand that your query gets vectorized and then shot off to find nearest neighbors, like you'd be able to still develop these applications. But when it comes to being able to explain this sort of stuff, if you're like looking to sell these solutions, you're going to want to understand this to explain that to your clients or to explain it to business partners so that they understand that you understand what's going on. But yeah, any questions about this, drop it in the comments. I'm sure there might have been some stuff that I didn't touch on, but that is just, a quick visualization breakdown that I wanted to bring to you guys because I think it's important. So thanks.